Hello everybody, welcome to CyberDucky. Today I just want to summarize what I did in my second day of network CCIE preparation. So in the day 2 I have covered, have learned few topic in network design, enterprise network design. So one is tier 2 and tier 3 design. Then I have the on-prem versus cloud. So I'll try to explain what is the difference between on-prem and what is the difference between cloud design and how they're going to integrate, and those terms and possible scenarios. Then redundant design. So what Cisco talks about redundant parts. Then the fourth one is the first hop redundancy protocol. So what is this protocol, how it used. Then the last topic will be state for switch over. So we look at layer 3. So the layer 3 is design, tier 3 design is that you will have a access layer, so where you will connect all the endpoints like computer, Wi-Fi or whatever, it should be connected here. Then you will have a distribution layer, which is this layer, it will be connected to access. So usually, let's say it will have two switches in the distribution usually. So this one will be the stack to each other, then it will be connected like this. The reason being is that if one distribution switch goes down, still there is a connection between the core. So this one is distribution. Then we will have a core layer where all your VLANs and VLAN routes and routings will be usually. So this will be connected like this. Most of the cases be stacking. Then this will be connected to this switch. So again, the same thing. So if this one goes down, the endpoint connected here has a full access to the internet. So that's what it's trying to achieve, is the high redundancy. So no matter what happen, what link goes down, still the network connectivity is there. So that's what about layer in tier 3. And the difference between tier 3 and tier 2 is that in tier 2 they will combine the core and distribution. So instead of the putting one of the layer like physical switches, they don't do in the layer 2, they do directly the access switches will be connected here. But here also you may have more than one switch to give you the redundant. Again, core, maybe this one 2, this one is 1, they are connected to each other. Again, this one is access connected here. So this type of scenario. But this one usually you will see in a data center environment where you will have a racks, like few racks, where you have your servers. On top of the rack you will see this access as called top of the rack switch, TOR. Then you will have one TOR. Then you will have one network switch somewhere in network rack somewhere where your routers and core switch will be connected. So this will be connecting to these core switches here. So both core switches will have dedicated connection to both the access switch. So this is usually you will see in a very small data center environment, but usually for the corporate or campus kind of a network where you have let's say a big building and you have 1, 2 or 3 floors, maybe the factory, maybe this one production, this is production 2, production 3. So in the IT area you will have a core, 2 switches, then you will have here one distribution and two distribution for each level, two switches as a distribution. We have stack. The same thing will go for every flow. Then they will have a fiber optic cable directly coming to core switches. So this way all the switches are directly connected to the core, and then you have excess switches, maybe few for each area, maybe here 2, maybe here 4. So all of them will be connecting to these two switches. So this is how the network usually planned, so the campus network. And then if you have Wi-Fi also, they will be usually connected to the access port, depend on the design again. Some cases you can even see the access point connected to distribution. So it's actually the preference or the business requirement as well. So that is the summary of the story when it comes to design tier 2 and tier 3. And the important thing to take note that the high availability when you design, then performance, core switch should have higher bandwidth, throughput and processing power compared to distribution and access switch. So access switch should have more ports compared to distribution. So that's other things. And most of the time distribution connectivities are fiber, and the core to distribution also should be fiber, and the fiber from distribution to access. So this one gives more higher bandwidth. Let's now we look at on-prem and cloud design. So the on-prem, the idea is that you have already the network is set up in a local environment, let's say you are a financial service or a factory or manufacturer. So you will have your building, then in your building you will have a dedicated area called IT room or something like that. Then you will put all the racks, and you will put network switches and servers, everything, and you will host all your services over here. And so that's what basically the on-prem means. So the problem with on-prem is that the investment, everything you need to buy, let's say you want to run a new project, only it will run for 2 years, then still you may need to buy a new rack. If you don't have enough space, then you need to have a new hardware. If you don't have enough power, resources. And then the bigger problem comes if it is like a 24/7 and you cannot have any interruption or disruptions. Then you need to worry about your power sources. You need to have at least two powers coming, one for UPS, one for direct power. So these are the challenges over the time we have seen. So that's why there are new solutions comes to the market called cloud services, where company sorry about my cloud, maybe AWS or Azure or Microsoft, then Google, they are providing services. So what they do is the same thing. They will have all the resources within their data centers located globally, so you can rent the services from them, like maybe per hour. I think usually billing per hour to run a server maybe cost like a 60 cents, $1. So it depends on the resources how much you want. So example in what we saw is that, let's say you want to run a project only for 2 years, then you can sign up with Google or any of the providers, even Amazon or even Microsoft Azure, and you can run as long as you want. Not only that, let's say you have requirement, maybe you have like 1,000 customers always coming to your site in the during day, but in the night time you have maybe 100 customers. So based on that, it can auto scale also how much your resources need to be used. So that's why most of the people now going to cloud, because it's a deployment is very easy. No need to buy hardware and no need to do any big investment. It's just open an account, then immediately spin between VMs and design network, connects them and allow them to connect globally. So that is the best thing and good thing, but the trouble here is some companies still have the old network where they may need to connect to the cloud. Also for that they may need to use a VPN. There's a few type of VPN, and one is using normal VPN, like there is usually they provide like a routing service, so you from your firewall or router from your local environment you will connect, then you will access all the resources. Or maybe there is something called a dedicated VPN that you can buy a link from any of these companies, whoever your cloud host, then you can connect them directly. So you will plan all these. This is the difference between this will become like a hybrid, like you are running OnePrime and your cloud, so this is called hybrid. So I think the summary is that there's a two type of network in running. One is called on-prem, you run in your own environment. Second is the cloud. Cloud is where you rent something like you rent, as they call it, infrastructure as a service or application as a service, so software as a service. So it depends what kind of a service you are running. So if you're taking as infrastructure as a service, then you will need to put in a VPN to send your local data to the cloud. It depends on how things need to be run. So the most important thing we need to understand is that there is something called cloud, and it need to be connected through VPN. And the VPN, there is a few type of VPN. One is connecting to using public infrastructure or internet, connecting between the on-prem and the cloud. Second is dedicated connectivity, using dedicated connection through an ISP or through a provider. So let's say we have one router which is corporate HCORP, maybe this one is HQ router, and we have already an ISP1 connecting to internet. So let's say all the users connected to this particular network, they will be connected like this, and whoever connected here, they will go internet like this way, then they will go to our cloud internet. Then you want to improve your redundancy for internet, you will add one more ISP, then call ISP2, then they will be connected here. So the challenges will be there, but again, there'll be a lot of challenges how to manage this load balancing, but it's not a it's as a design concept, we can connect these two, then we can put some policies to balance here. So let's say this one is PC1 and this one is PC2, then you can say PC2 through the ISP2, PC1 for ISP1. If it goes down this one, then PC1 2 both will using the ISP1. So this setup gives you more resilience or redundancy, and it gives increase in throughput. Maybe this one 100, this one also 100 meg. So when these two operate at the same time, these two systems may get higher output. When it goes down, then there'll be some challenges, because they used to have dedicated connectivity, then now they had to share the 100 meg between themselves. So there are some challenges will be there, but as a design concept, yes, it's possible. And we always need to think as a network engineers that how to have a high redundancy in your design, so that no matter what kind of a failed happen in a network, but the production it will be continually operating without any impact to production. Okay, let's look at first hop redundancy protocol. So before we get in deeper understanding on this, for when come to first hop redundancy, we have three protocol, which is HS HSRP and GLBP, and we have VRRP. So these are the three so-called first hop redundancy. The first two are Cisco proprietary protocol. This one is common or the publicly available protocol, which means, let's say you have one Cisco and you have one Juniper routers or switches, and you want them to act as a gateway together, then you'll be using the VRRP. And if you have two common or Cisco routers, you can go these two, HSRP or GLBP. The GLBP and HSRP is a big difference is that HSRP you cannot do any load balancing, and GLBP can do load balancing. That's why the name is GL is already there. Gateway Load Balancing Protocol is a full acronym. So let's see how it's benefiting us. So let's say we have two desktop, let's say PC 1 and PC 2 connected here. Then we have one ISP example, let's say ISP 1, and this one is maybe the local IP address is maybe let's say 1.1.1.254, and this all in a one series, let's say 1 and 1.1.1.2. So these are the two IP addresses. When they want to go internet, they go through this ISP link to internet. So then we want to improve our redundancy. What we do is we get one more ISP and we put it here. So this one is ISP2. This one is ISP2. It has maybe global IP, let's say 101. This one maybe 100. So this is the global IPs. So later we discuss what are those things. And now the trouble is you want to use this one also now, because in the system, and if you go to desktop settings, you will have only one gateway. You cannot put two gateway. So gateways are necessary for systems to go internet or any other destination which they don't know. So that's why there is a something called gateway. So the gateway will know, all the IP routing information to send the packet to where. So the challenge is we cannot put, manually maybe we can say 1.1.253 of this IP, local IP. Maybe we can change it here, but the challenge is if this one of the network goes down, let's say if this ISP goes down, the number one, manually you need to go and change the gateway again. So this is a troublesome. So that's why we use these 2 or 3 protocols. So what they will do is, so they will use something called virtual router. So this let me correct this one. So let's say we will put manual IP address or hardcore IP address in this router. This is 253 and this one is 252, maybe 1.1.252. Then there is a virtual router will be 1.1.1.254. So we know 254 is the gateway in all these 2 PCs. So even any of this one router goes down, that this one will be remain as a one, the virtual router will remain, and these two will be act as a master and slave depending on the configuration. So let's say master go down, this one take over as a slave will take over, or the passive will take over the active. So there is some depend on which protocol, which term is called is a master or active. So when if it goes down, even it was connected here, still these two will be able to go through this router without any drops in packets. So that's a good thing. And the other good thing about is if you're using GLBP Cisco product, Cisco's protocol, we can round robin, or we can say, okay, we can put some configuration based on like a algorithm. So one maybe will go through one, two will be go through two. Then if anything happened to any of these router, the one whoever take over, they will allow both of them to go to internet using same gateway what we use here. So that's about the first hop redundancy. The things we need to take note as a summarize. There is a 3 protocols. 2 belongs to Cisco, which is HSRP and GLBP. VRRP is a industry standard. It be used in many vendors, including Cisco, Juniper, you name it. Almost all the vendors are using it. And the second thing is there are other terms, and later video, and eventually when I go through maybe my practical lab scenario comes in the upcoming days, then I will try to demonstrate how to configure these setups and highlight what are the things we can change, like for the GLBP you can do load balancing, all this. So the important thing again need to remember is these two belongs to Cisco, but this is industry standard. Only GLBP can do load balancing. So that is the most important things to take note. Let's look at stateful switchover. Yep. This one, let's say this one is router 1, R1. This one is R2. And this two has a JSNC, maybe OSPF, or whatever the routing protocol you're using. There is some JSNCs involved. So let's say this processor in this one is failed, then it will lose the JSNC's informations, whatever is holding. So that's where the stateful switchover comes in. So if you have stateful switch failover, and let's say this processor failed, they will have a backup processor. It will send this configuration information to this every depend on every minute or every second or maybe every 10 seconds, so that all the informations are running available here. So if it is failed, then its second processor will take over. And then there is something called non-stop forwarding, where all the routing informations, so the we call Cisco Express Forwarding, will hold those informations in the memory, and then it will be keep maintaining the JSON between R1 from R2. But again, for this particular configuration, I think you may need to have 2 processors, if I'm not wrong. So it all depends on which kind of a model you're using, a router, and how much processor it can support. So this is very much technical in a sense that you need to go through Cisco documentation and understand this. But the concept is, end of the day, that you are learning the concept. So just to understand that concept is that it's something like a seamless failover capacity or config or feature for using the SSO and NSF, which is non-stop forwarding. And I hope this video for today will be helpful for you guys. This is my second day as I'm trying to learn and summarize my learning for CCIE. So we have done now day 2, maybe day 3 or day 4 I will cover other topics. So once I get into more advanced topic like switching, routing, I'll try to do a demonstration of every lab I do, so that it will be more benefit. I believe it will be helpful for anyone who watching this. Please help to grow this channel, so that it will be great motivation for me to keep doing every day. And please comment if you see any issues or anything, any help you need, and I'm happy to reply whenever I have time. and thank you again, and have a great day. See you again.